on. Yeah. Let me just do this one little thing just to make sure all the slides are here. Okay. So architecting fundamentals, TTO feedback, the different questions and objectives. Here's our crazy high level diagram that we're going to be focused on. Okay. So here we're going to focus mainly on the general swath of AWS services. We're going to talk about the AWS architecture, and I'm going to mention the well-architected framework. Why am I not deep diving into the well-architected framework? Because we're going to cover pieces of this whole thing as we move through, right? As we move through all these services. Now, which AWS services should I consider and how do I manage them, right? Basic questions, right? So which services should I adopt? What are the different service categories? How do I use AWS? What's the difference between managed and unmanaged? And what kind of lies is Michael Forrester going to tell you when he says the word serverless? That's really what you should take in, right? Just whoo, woosah. Okay. Now, here's what you need to know is that if we go over to a web browser and we type in AWS global infrastructure map, we can go to Amazon's global infrastructure webpage, and guess what we can see is we can see all of the cool little geographic areas that Amazon has what they call regions in, okay? Regions are made up of availability zones. What are availability zones? They are clusters of data centers. But you're like, hold on, Michael, hold on, stop. You just said a region was made up of at least 2 or 3 availability zones, and you just told me availability zones were clusters of data centers. Does that make a region a meta cluster, like a cluster of clusters? Yes, it does, right? So know that inside of each region, you have these clusters of data centers called availability zones. There are typically anywhere from 2 to 3. Sometimes there's 4. One of them has 6, but there's usually at least 2 or 3 inside each region. So if Amazon says, hey, guess what? We have something in Sevilla, we have something in Spain, right? That means that somewhere in that area, they have 3 clusters of data centers that are coming soon, apparently. Those clusters of data centers are called availability zones. And when they have a failure, it's typically going to be along, you know, an availability zone, unless you count last week and the week before. Well, actually, just to say that those were regional failures, and one of them was a global failure. God, we hadn't had a global outage with AWS in a long time, actually. But man, to have 2 back to back, whew, my buddies were sweating over there. I was not involved. So just to say this, a region is made up of availability zones. When you run anything with a network card, it has to run in a data center in an availability zone. Now, these regions and these data centers, availability zones, all have codes attached to them, right? So if a region is called US East 1, because we're talking about Virginia, if I say US East 1A, I'm talking about the first availability zone. If I say US East 1B, I'm talking about the second availability zone. And just so you know, not everyone's A is everybody else's A. So Amazon likes to rotate the letters around so people don't get strapped up in a data center. So just know, though, that they add letters to the end of the region codes in order to delineate the data center, the availability zone, versus the actual region. Amazon runs services in 3 ways. If it has a network card, it has to be in an availability zone in a data center. If it is a regional service, then it actually runs in a regional data center that is not the same data center as the availability zones. Weird, right? So let's take a stab at this just from a quick annotation standpoint, because I just want to make sure I'm kind of clearing this up for you. Let's say that this is the Virginia region. And, you know, yeah, it's hot pink, so just deal with it, right? And inside of that, there is a red availability zone, another red availability zone, another one. And since, you know, it's Virginia, it's going to have 6 of them. Now, this is known as US East 1, as you're all familiar with. If I want to talk about the first one, I would call it A. If I wanted to talk about the second one, I would call it B. I would call it C, D, E, and F, which means it would be US East 1B, US East 1C, etc. Now, just so you know this is when we were running something that has a network card. What has a network card? An operating system has a network card. If I run a Lambda function, which is serverless, but I attach a NIC to it, it's going to run inside of a data center. If I decide to run a container, which runs on virtual machines, and I run those virtual machines inside, right, it's going to be inside of an availability zone. Now, if I run DynamoDB, which is completely serverless, and that's a regional system, it's going to run inside that pink region. But just so you know, invisibly to us, there's another set of data centers that are regional data centers. Why is that red again? Hold on. That are regional data centers that also sit inside of a region. Now, we can't access them, we can't touch them, but they're there. So just so you know, Amazon runs things at an availability zone level, at a regional level. And if I involve more than one data center, because it's like DNS as an example, which is, was part of the outage from a couple weeks ago, then if I've got other regions involved, it runs globally. So DNS, for example, runs globally. CloudFront runs globally. Now, CloudFront is a little different because it also involves other locations. But the main thing you should take away from this is that regions are comprised of 2 or more availability zones. The availability zones are the data centers, right? That's where the actual network cards live. Christian, I like it. Data center is a cluster of servers, right? Totally. I have nothing to add to that. All right, going back to our drawing. So Amazon has a ridiculous number of regions, right? So if we look up, what is it? Currently 26 regions around the world, 8 more regions in Canada, blah, 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 UAE. So they'll be at 34 here soon. So that's the whole region and availability zone construct. When you put data, for example, in S3, which is a regional service, you have to say which region is going to be the home for that data. If you launch an EC2 virtual machine and it has to live in an availability zone, you have to say which region and which availability zone is that virtual machine going to live in. If you say, hey, I want to create a global DNS record, you don't have to specify which region that DNS record lives in, because that's a global service. So remember, there's 3 levels. There's global level, there's regional level, and then there's the AZ level. Okay. By the way, the global level also includes the edge level. So that includes all the like little edge servers that are sitting all over the world, if you haven't seen those. But don't worry, we'll talk about those in just a second. Now, customers go to AWS, not just because of their amazing global infrastructure, because let's be frank, Google and Microsoft were into this space well before Amazon was, right? But Amazon's data centers are new. And they did a lot of proprietary stuff to make them fast, but I don't know. I think they're pretty much all the same now, regardless. Now, service-wise, things are not the same. Now, don't get me wrong. Virtual machines and other providers work very similarly to what's inside of AWS. But the thing that's cool here is that AWS has a broad swath of services that can meet pretty much any use case you have. The other thing that's horrible about AWS is that they have a broad swath of services that can really confuse the junk out of you whenever you want to do something, right? So just know that, for most of us who have specific cases, we can actually find the service that we're looking for. So, if you want a quantum computing service, well, they have one. If you want an augmented virtual reality service, it's called Sumerian. They have that too. If you want, a robotics process automation, RPA, they've got that. If you like a ground station for your satellites, you think I'm making this up, I'm not. They really do actually have a service for, it's called ground station. And you can just click on it if you want to sign up for it. Now, all that being said, we're only focused on core services. And repeat after me, application hosting. Yeah, Gesundheit. Application hosting, that's what we're after. We're not after machine learning, which is awesome, right? We're not after satellites and robotics and all the other stuff. We're not, right? Those are different classes. And by the way, Amazon does have classes on all this stuff. So if you're interested in learning more about SageMaker or practical data science, or you want to learn more about running containers, or you want to learn more about, planning and designing databases, they do actually have classes for all this stuff. I don't make any money off of that. I'm just letting you know in case you are interested in that. Okay, now as an architect, our main focus is to plan, research, and build, right? We got to stay abreast of, new technologies that are coming in. We got to figure out how they work and function. How do they work and function at scale? How do we make them work and function for our company? And then we got to build it. Now I know, people are like, well, if I'm an enterprise architect, I, do some of that, but I don't actually do the building. If you're a solutions architect, you live at the boundary of integrations, right? So a solutions architect is a step below an enterprise architect. Your job is to actually help people build stuff, and your job is to help, obviously create evolutionary architectures, ones that will not put you in a corner where you have to rebuild stuff, right? Ones that offer flexibility. Okay. So obviously there's some technical strategy pieces and analysis pieces here as well, right? Designing prototypes and whatnot. Now, the sample architecture that's here, a solutions architect has to know how services interconnect, right? And how they work, how they're available. Unlike a software architect or even an infrastructure architect or a systems architect who's really working at a really low level and more componentized, a solutions architect is operating at the boundaries where two services interconnect and meet with each other, right? And there's a lot of overlap between those levels, and there's a lot of overlap with that with an enterprise architect. But this kind of design methodology, which is, this is a pretty actually basic setup. I know that sounds weird to say, right? But by far not, one of the most complicated ones that we could set up. But this is where we're targeting. By the time we hit the capstone lab, by the way, on day 3, you are going to be able to build this, and you are going to build it because that's what the capstone lab is for. Now, how do we connect to AWS? Well, hopefully you already know the answer to this. Is first of all, the management console, which I think you saw me shucking with here just a minute ago, right? Oh no, I didn't actually click on it, right? So notice that I'm in Ohio on the upper right-hand side. I'm in US East 2, right? And oh, apparently I have a keep here. Oh, that's right, I was messing around. So this is where I would, if you're going to use the console is great to learn. Console is great to verify. Console is not great to scale, right? If you want to scale, the main thing you would use is the command line interface. So this would be, I think you saw me, I was messing around with the library or something earlier. Oh, that's right. I was trying to figure out why Jenkins wouldn't start my Kubernetes cluster because it was giving me a bunch of errors. But it actually turned out to be a terminal problem, not a Kubernetes problem. Let's see. So for example, this would describe all the EC2 instances that I have inside of AWS. I guess it's a system that I shut down. Regardless, this kind of command line where you're describing instances and initiating instances, and that's one way to scale as well. But the other way is infrastructure as code, which is what most of us do, which is CloudFormation, which we're going to talk about on day 2. Okay. The last way that gets used a lot is things like the CDK. The CDK is the Cloud Development Kit, software development kits, basically libraries that get imported into your favorite language that allow you to create AWS objects and use them. So that's the whole purpose of that, is so that you can actually do infrastructure as code, check that into a repository, and then execute the build of your AWS services as a result. Okay. CloudFormation is the native tool that integrates well with AWS. Obviously, the CDK and the software development kits, blend in with your favorite language of choice. I would be completely remiss if I didn't mention something like Terraform, which is pretty much the industry standard for cross-platform, cross like cloud, infrastructure development. It also uses TF files, which are kind of like CloudFormation with their own proprietary language. It's the HashiCorp HCL. So just know those are the 3 main ways, right? Is that you can use the cloud development kit, you can use the software development kits, you can use CloudFormation for infrastructure as code. By the way, if you're using the CLI, make sure you're using version 2. It's been out for a while. It's got Bodo kind of like folded in. All of these, by the way, are just vehicles for getting to the API. The API is the core management system here, right? This is the core interface for how you manage and create software-defined infrastructure in AWS, right? So That's the core way it's done. Yeah, Christian, I think I last saw is that Boto 3 is all folded into the binary. So you don't have to have Boto installed separately. It's actually included inside the system. So management console, as we mentioned, right? You can do a lot of things with it, but it's mainly for verification. If you're click provisioning your resources, I would strongly encourage you to either learn how to do it with either CloudFormation or Terraform if you're going to do that, because that's a reproducible, scalable way of approaching it. Now, in terms of services, just be aware that not only do we have those 3 ways and we have all these locations where we can put stuff as far as availability zones and data centers and whatnot, Amazon really wants you to use managed services, right? And the reason for this is that unmanaged services, all the operational responsibility is on you. If you use managed services, then all that comes off onto them. It's not necessarily orders of magnitude more expensive also, just to be frank about it. And in many cases, actually, it's more cost efficient and cheaper because you're only paying for what you use. When you do unmanaged services, you pay for capacity. If you ask for a 4 processor 16 gig machine and you use 10% of it, you're still paying for 100% of those 4 gigs and 4 processors and 16 gigs. If you run a DynamoDB database and you eat 5 reads a second for 5 minutes and then you don't do anything for the rest of the day, you pay for those 5 reads a second for 5 minutes and that's it. So managed services, and don't get me wrong, you pay for any storage space, but typically it's going to be cheaper than running your own NoSQL database. So just know that Amazon, in terms of certification answers, is always going to be pushing towards managed services, okay? Other things to note is that, you didn't really see any serverless inside of our setup for our diagram. Just know that the serverless services, one, do not operate inside of a VPC, because you may remember I told you that there are data centers inside of a region that are region-specific data centers. They're not availability zones. They're for AWS use only, and that's where they run S3, DynamoDB, and all those other services, right? So just know we're going to talk about how to incorporate those kinds of highly, serverless services inside of our design, but we're not. It's going to be part of our build, but it's not going to be part of the major core of the design. Other thing to note is that AWS has great documentation, which they do actually. They do have good documentation. It's very readable. It's not perfect. No documentation is, but if you go to docs.aws.amazonaws.com, you can actually get access, or just search for AWS documentation. It is all over the web, indexed highly, widely available. So all of that was just to talk about, hey, here's where your services and data are going to live at a high level. Here's some ways in which you can actually interact with AWS. They're all just reminders of stuff that you would have seen actually at the cloud practitioner level, and stuff that you've probably already done because you've probably already visited the AWS documentation. You've probably already launched EC2 instances. You've probably already used the command line. Okay. Questions before we talk about the infrastructure at a little bit deeper level?
What was that Nitro enclave on the previous page? Yeah.
So Amazon has created their own host-based instances to host virtual machines. They call it Nitro. And it basically is them kind of like hyper converging the CPU, the memory, and the disk and the networking into a high-speed host chassis for virtual machines. So you can read more about it, obviously, because it's all over their documentation. But anything that's Nitro enabled is typically a faster virtual machine than if it's not Nitro enabled, right? Which, by the way, just to say this, almost all their stuff now is Nitro enabled. They are moving towards that as the de facto. So they've learned to make the virtual machines faster. Thanks. Yeah. By the way, you don't have to do anything special. I don't even know why they have a user guide for that. It's not like you have to do anything extra. If it's an ARM-based enclave, though, it's a little different than an x86. But honestly, that's just a matter of making sure your operating system supports it. So, and your software does. Otherwise, there's nothing for you to know other than it's faster performance. Okay. Who's going to control where our resources run, right? How do we deal with latency? So we've already talked a little bit about data centers, availability zones, regions. We're going to add local zones in there, and we're going to add edge locations, which are where CloudFront and Route 53 and a couple other like global accelerator runs, okay? So the data centers we've already talked about, right? These are called availability zones. Well, they're really clusters of data centers, but you get it, right? An availability zone is going to have more than one data center in it, but these are all going to be fault isolated. So power, cooling, internet, all of that is going to be isolated for these availability zones, right? They're going to be isolated from each other. So each AZ is independent from any other AZ in a region. So that way, if an availability zone goes down, that's why Amazon at a minimum says you must run 2 virtual machines across 2 availability zones, because Amazon wants you to have redundancy. They want you to have a good experience, and they're not sitting there saying we're not going to have a failure. What they're saying is that we're going to have a failure, and typically that failure is going to be in an availability zone, not across 2 availability zones. I know that's not what happened last week, but typically that's what happens. The last 2 weeks was kind of a rarity, to be frank. So anyway, let's hope that doesn't happen again for another couple of years. Now remember, regions, right, are the meta of, they're comprised by availability zones. Now each region is also completely independent. And just to be clear, when you transfer data into a region, Amazon's not going to charge you anything. When you take data out of a region, Amazon's going to take some money, right? It's like 0.0000 something per gigabyte, just so you're aware, right? So when I say, hey, I'm in the Tokyo region, and I say I'm in, what is it, AP Northeast 1A, right? That means I'm in the first availability zone for Tokyo. So just know that each of these has a code, right? US East 1, EU Central 1, right? Just depends. How do you find the codes, by the way? Well, you can look it up in the documentation, but you can also just look on the, right? So Tokyo is AP Northeast 1, as you can see here. Canada is CA Central 1. You can look on the console, or you can look in the documentation to find it. Now, here are some factors that are impact region selection. First of all, are you allowed to do it there? Now, for most of you, that's really easy because you operate on GovCloud. You can't even use the private, or I don't know if it's public, the public AWS instances. You have to use GovCloud. You have your own interface to that. It's already pretty controlled, right? So governance is going to control where you go. By the way, if you're looking for quantum computing as an example of service availability, that only exists in certain regions. So you got to look up the AWS service map in order to find out whether a service is available. If you're like, hey, I really want to do quantum computing in Mumbai, and it's like, well, we'd all love that, but AWS hasn't put it there yet, so don't know why. The other thing is latency, is that you want to host services close to your users. So if most of your users are in Japan, don't put your web servers inside of Virginia. That's just common sense. You probably know how to do that already. Now, the last one that most people don't know about is cost. So just so you know, on every continent, there's typically a region that's more expensive than the others. For example, California went down last week, and I was like, great, because no one should be using California. You know why? Because it's like 10 or 20% more expensive than any other region on the continental United States or in North America, really. So it's like, when all my buddies are talking to me and they're like, hey, we're using California. I'm like, why are you using California? They're like, it's 10 or 20% more expensive. They're like, what? I was like, yeah, go do a cost analysis. And I was like, where are your customers at? And they're like, the customers are on the West Coast. I was like, well, then go use Oregon. And one of them came back to me and said they've been spending $10,000 extra a month just because they decided to be in California for some project. Bottom line is that, unless you're in GovCloud or some other private AWS function, check your costs, right? Germany is typically more expensive than Frankfurt's usually more expensive than the rest. Tokyo is typically more expensive, or it was. Amazon's trying to normalize all that, but quite frankly, I think they're just going to retire California. So we'll see how all that goes. So remember, 4 factors, right? Governance. So are you allowed to be there? Latency. What's the fastest performance for my consumers, my users? Is the service I need there? Service availability. And then costs. So how much is this? Is this more expensive or less expensive? Now, just because Amazon wants to occasionally confuse you, but also to make applications closer to your users, they came up with this special availability zone called a local zone. You're like, Michael, what does that mean? All right, imagine with me for just a second, right? Let's go back to our picture. So let's say we're looking at our service map of global infrastructure. Actually, do they have a map of local zones? Let's just take a look here for a second. Oh, they took it down. All right. So imagine you're here and that for some reason you decided that the city of Boston came back to you and said, you know what, Michael, we geography, let's just roll with this for a second. They're like, hey, we need to actually put an application here. We need to put an application down in Miami, right? We want something over here in Texas. We need something in Kansas. Let's just, and you're like, well, hold on. The data centers in AWS are pretty much East Coast, West Coast, right? They're not necessarily going towards the center. What a local zone is that's where they took an availability zone, but instead of sticking it inside of a region, they actually stuck it near a major city. So a local zone is just AWS taking an availability zone, so a cluster of data centers, and they just stuck it inside of a major city. So Boston, Los Angeles, Miami, I mean, there's like a list of 14 now. It's like kind of ridiculous. They only had 4 as of 2020, and now they got like 14 or something crazy. So if we go take a look, let me clear out my drawings here. We go take a look at the number of local zones. Where are these things? Let's see. Because they disabled some of these links, which is kind of interesting. Da, 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 da. All right, so look at all these local zones that they're starting to create. So these are places, oddly enough, where they already had edge locations. But just to be clear, an edge location is just a rack of servers for the most part. Amazon apparently decided to expand on this footprint, and they created 30 local zones around the world. These are single availability zones, so a cluster of data centers that's been set up near a major city. So as you can see here, right, they've got a lot, right? So, oh, this isn't even interactive. Wow, they've really changed a lot. Chicago, Dallas, Denver, Kansas City, Las Vegas, et cetera, et cetera. What they've done is they just stuck a cluster of servers there. They stuck a couple of data centers there, and there they are. Now, notice this says US West 2, Denver 1A. This says US East 1, Boston 1A. So just so you know, local zones are associated with a region, but that region is typically nowhere near where that city's at. Like it's close, but you know what I mean? It's not like right there, right? So just so you know, if that availability zone fails, that local zone fails, it's going to fall back to US East 1, which is what, like 600 miles away or something like that. Same with Chicago, same with Dallas. Notice that the prefix in the zone name determines which region it's going to fall back to. So, something to be aware of is that these are single points of failure. Now, as much as a single availability zone can even be a single point of failure, but I think you get the message, right? These are not going to provide high availability. You actually have to put servers in a local zone and in a region if you want to have some kind of fallback. But this is another location where you can run and host your applications. So virtual machines, containers, I don't know that they run serverless like Lambda yet, but they definitely run virtual machines and containers inside of these local zones. So remember, regions are comprised of availability zones. Sometimes Amazon will allow you to get low latency by putting your servers inside of what's called a local zone. That zone is local to a major city. And if it fails, you have to fall back to a region, which is typically a couple hundred miles away. Questions of any type? Okay. By the way, the use case for these is if you need single digit millisecond latency to your end users, you're going to use a local zone. Otherwise, just keep it in the data center. Just keep it inside of a region at that point in time. Right. So this could be, by the way, augmented reality. Like I'm sure like the metaverse, right? Not that Facebook isn't going to roll their own. I'm sure Amazon's going to surprise us as well. This is really for low latency inferencing, low latency gaming, low latency, immersive environments, right? Okay, So in addition to regions which have AZs, local zones which sit outside of the regions, we have these small smattering of servers that basically sit even outside of that. So, because remember, a local zone is still a cluster of data centers. A region is a collection of clusters, it's like a cluster of clusters, right? An edge location is even smaller than that. And Amazon has like 300 of these edge locations all over the world. And I actually had a guy in my class like 4 weeks ago who was an installer for these edge locations. And what he did is that they actually went to every major ISP in almost every major city, and they would install a rack of servers. That rack of servers would act as a caching mechanism. And by the way, I say a rack, there would be multiples, and they would be redundant. But what this is that this is where Amazon caches your web content when you turn on a service like CloudFront. When you enable something like Global Accelerator, which allows you to fail over between regions and get redirect a user, these are the systems that are actually interpreting those calls and returning millisecond response times, right, to the users. So these are the edge locations are incredibly important because they're even broader in reach than what's happening inside of regions and local zones, and they sit all over the world. And Amazon was smart about this. They're basically anywhere there is a major internet service provider in a major city, which is pretty cool, actually. It's a smart way to do it. So instead of going all the way back to Amazon's like US East data center, US East 1, you would instead, I would go to the Atlanta server, like the caching server that's here, talk to that server, and that server would proxy on my behalf using Amazon's high-speed backbone, not over the internet. So it's actually pretty cool the way they do that. And since you're hitting with your slower connection, a server which has a way faster connection, when that server goes and proxies on your behalf, they pull down more data quicker and then can feed it out to you almost immediately. So remember, regions are comprised of availability zones. Local zones sit outside of regions, closer to major cities, but they are in a sense availability zones. And then we've got these edge locations scattered all over the world, and these act as caching and DNS proxies and network proxies on your behalf. Just to say this, you cannot specifically put data and put like your like hosting services on edge locations. For regions, availability zones, and local zones, you can actually specify, I want to run my Java app here, but you can't do that with edge locations. Edge locations are controlled for you automatically. A good use case for this, video. So if someone comes in and says, hey, I'm in China and I want to access a video in Brazil, you'll actually hit the edge location first, which will then run down the network pipe, the private backbone of AWS to hit the source server. It will feed it back to the edge location, and then over the internet, the edge location will feed out the file in question. The second, third, and fourth users in China who hit that same URL, it won't even go back to the source because it'll just go off the cache copy that's in the edge location, depending on what your time to live was for your cache. Okay, so you get to control that. So remember that CloudFront in these edge locations, this is a content delivery network. This is just a skim. If you don't understand what I'm saying, I promise you we're going to spend a whole hour or two on CloudFront. So if you're like, Michael, I don't even know what a content delivery network is, it's okay. We're going to spend some time on it, so you'll know. The main thing you need to remember for this is that edge locations are stacks of servers that Amazon has scattered all over the world. They act as caching mechanisms. That's what you need to remember. Other things to note. The difference between a local zone and an edge location is that local zones host applications. Edge locations really just act as caches. If you need single digit millisecond latency, look at local zones. Edge locations can provide that, but again, they're not hosting applications. They're just trying to deliver copies of content that you already have in another location. Local zones are an actual location where you can host applications. So edge location's job is to drive latency down. Local zones have the exact same purpose, which is to basically drive latency down. But remember, local zones host applications, edge locations just cache them, cache the results. Any questions about regions, availability zones, local zones, or edge locations, which of course scattered all over the world? Christian, that's a great way to say it, right? The apps should be interactive if they're in local zones. Edge location can front an interactive app, but it's mainly, as you said, for caching and streaming. Okay. Let's talk about the well-architected framework, right? The one that there was a pillar I couldn't remember earlier, right? Because I said security, reliability, cost optimization, performance efficiency. And I think I forgot the one that I should have actually remembered the best, which was operational excellence, because, right? DevOps. Note that, by the way, they added a sixth pillar called sustainability 3 weeks ago. So, okay, Michael, why do I care about the well-architected framework? Here's why you care, or why you could care. This is a filtering function that allows you to determine whether or not you're building cloud-enabled, like AWS best practice architectures. So if you're worried about security and cost optimization, reliability, which we all should be, then this is a great set of questions that you can ask about your workload to identify how you're doing with cost optimization and how is operational. Are you using infrastructure as code? Are you testing responses? How are you recovering and designing for failure? And so there's a tool for this called the well-architected tool that will, allow you to identify the workload, and then you can conduct an architectural review and then apply the best practices in question. So just know, and by the way, there is a white paper for not only the framework as a whole, but a white paper for each of these different sections. Here's a funny story. The gentleman that kind of headed this up 10 years ago with AWS, well, he went to work with Microsoft. So oddly enough, when you learn these pillars, you learn the pillars over at Microsoft, because he published a new paper, which looks remarkably like the old paper, but at a different company. So yeah, that. So anyway, these are actually pretty solid architectural frameworks. Very familiar with TOGAF and other things that actually offer the same kind of insight. Those can be a little heavier. This one's pretty thin, but do note that you do need to at least know like what each of these particular pillars, what they provide as far as like what's listed here, right? Where would monitoring and metrics go, right? That would be operational excellence, but it also fuel things like performance efficiency, cost optimization, to a certain degree, security, obviously reliability. So just know you want to have a general idea of where things live. Skimming the white papers, which is actually part of the study guide, not a bad idea. Okay, let's do a knowledge check, and then what we're going to do is we're going to take a break. Okay. Which infrastructure as code, because remember I told you we're going to drown you in acronyms, which infrastructure as code automation service deploys AWS resources at scale?
CloudFormation.
Thanks, John. Yeah, CloudFormation, right? So that would be D. Good. Do me a favor, by the way, type your answers if you don't mind, so that we can get everybody's answers. Which of the following are a cluster of data centers within a geographic location with low latency network connectivity? A cluster of data centers within a geographic location with low latency, fault tolerant network activity, cooling, and power. Which of those? And A, B, C, or D, right? Good. Yep, availability zones, pretty straightforward. Okay, which of the factors do you consider when picking an AWS region? So I'm going to give you a thing here, is that service availability isn't here and cost isn't here. What are the other two that we talked about that will influence which region you will choose? So local data regulations, which just means, can I be there? And then of course, latency to end users are the other two reasons, other than service availability, other than cost. Location of your development team, like who are your consumers, right? If your consumers are the development team, then you should obviously choose that. But really it's a location to your end users, right? And then the number of availability zones, they typically all have 2. Now, actually, they typically all have 3. So most people don't care. We're not going to be like, man, I want to use 6. Because I can tell you, if you need all 6 availability zones, even in Virginia, most people just use 3. So, just depends on what your business requirements are. What is the primary benefit of deploying your application into multiple availability zones, right? Why does Amazon want you to deploy into 2 or more availability zones? What's their reasoning for that? Good, that's right. High availability for the resources in question. That's what they want you to consider. It's not security, although you might actually get some increased security from that. It's, certainly not stronger security policies. And decreased latency to resources, that could happen because of auto scaling, but that's not the primary driver. Primary driver is high availability. Okay, so this one's kind of an interesting question because it wasn't really covered. The principle of least privilege is a principle under which of the well-architected framework pillars? Good. That should be pretty straightforward, right? Security. Perfect. Okay. That is the end of module 1, which has us rolling right into a lab. Okay. So what I'd like for you to do is that you should have gotten an email inviting you to webage.quicklabs.com, right? And what we're going to do is that for the end of module 1, we're actually just going to deploy an EC2 instance using like all the 3 ways that we can do it, right? So we're going to use it using the console. We're going to use the CLI. You're going to use the CloudFormation template, and you actually have an optional second CloudFormation template that you can use. Now, what I'd like for you to do is go ahead and go to webage.quicklabs.com. You will log in using your Booz email or whatever email you use to register for this. Which actually, it looks like you all used your Booz email, so perfect. So log in using your Booz email. If you don't know what your password is, just click forgot password. If you haven't, by the way, confirmed and all that, which honestly, if you've taken a class with us before, you've already been confirmed, but you should be able to log into this. Once you get in here, you're going to go onto My Learnings and then click on your class, which should be Architecting on AWS. Once you're in here, the lab is actually already activated and it's already like pre-warmed, although one of them was in queued, but don't worry, that'll be for me, not for you. And then here you got the instructions, task 1, task 2, task 3, and then the optional task 4. And you're just going to follow the instructions. I enjoin you to please get very detail oriented. Do not skip a step. These labs are very recipe driven. And the reason they're doing that is that this is the process that you would follow to actually create an EC2 instance, right? So I encourage you to get into this and just be very detail oriented. Make sure you step by step, okay? Now, no, by the way, they usually give us 2 to 3 times the amount of time. This is typically considered to be about a 30 or 45-minute lab. It is currently 10 o'clock. So I'm going to check in around 10:30 and say, hey, how you doing? But you should be pretty close towards the end, right? One word of caution, do not sit here for the next 15 minutes and try to get logged in and don't ask for help, okay? Just because it's going to be frustrating for you to be sitting there and you're going to have like 15 minutes left to do the lab and then you're going to, anyway, the labs are not contingent upon one another, by the way. So if you don't get this one done, you can still do the second one. They all pre-build, okay? Meanwhile, go ahead and hit that start button up in the upper left-hand side. I'm not going to do it because it's going to take away one of your hot labs that I've already pre-warmed for you. But that's what we're going to do for the next 30 minutes. I'm going to stay here and answer questions for you. And then we're going to squeeze in a break here shortly, okay? So let's get on this until about 10:30.